The next two problems within this exploration are going to look at what if we knew the tangent value, can we work backwards to figure out the angle measure? We've done this already with sine and cosine, and so it's going to be slightly similar with tangent, and so we're going to sort of think through a few problems and then talk about the resulting function. So in this case, we have a circle with a radius of 1, and there are actually two possible positions on this circle that a terminal ray could hit that would have a tangent value of 1.5. Now the key here is to remember that that tangent value, remember, is your slope. And so it might help to actually write that slope as a fraction, and in this case that would be 3/2. So if I started at 0, 0, and created a line with the slope of 3/2, or a rate of change of 3/2, that would count up sort of 3 units as I go over 2, and I can sort of sketch in a line here. And ta-da, there is one of my terminal rays that would have a slope, whatever that angle measure is, would have a slope of 3/2. But think about that. That line could continue on the other side of my origin. And, that would be this entire angle. And so that would be the other possible angle measure. So notice that we got sort of two of them, and I'm actually going to make that second angle a different color just so we don't mix it up. We got sort of our two different sort of locations. Now, in this next question, we're asked to sort of estimate this first angle measure, and then how could we use symmetry in our estimation to come back to sort of what it actually is. Now, in this case, I know this would be sort of 0 degrees and this would be 90 degrees. And I'm definitely more than halfway to 90. Halfway would be about 45, and we'll call that, sort of 45 right there with a nice slope of 1. It's probably a little higher up there. That would be 45. And so we're looking for something above 45, but closer to 45 than it is 90. So, you sort of have to take a guess here. There is, this is an estimate. I might say, let's call it 55 degrees. It's, more than 45. It's less than 90, closer to 45 than it is to 90. And so if that angle is 55 degrees, remember we've talked about symmetry and reference angles. And so if we're thinking about it, this angle down here that I've sort of highlighted in green, that would also be 55 degrees. And so if I wanted to figure out sort of that second angle measure, I would take the 180 degrees of, half of my circle and then add 55 degrees to it to get approximately 235 degrees. And so those would be my guesses.
Well, an estimate's okay. We do want a way to get an exact or a more accurate angle measure given a tangent output. And so we can actually go through a sort of inverse process. We did an inverse process when we were guesstimating, where we drew in the slope and we sort of estimated where we thought the angle would be, but we can be a little more precise because just like with sine and cosine, there is an inverse function when it comes to tangent. So let's just do a little bit of a refresher from earlier in this exploration. If you remember, we were introduced to the tangent function, and so in the tangent function, we inputted an angle measure, and the output was the slope of the terminal ray. And so when we deal with inverse functions, our input and output quantities exchange. So now instead of my input that's an angle measure, the inverse tangent function is actually going to output an angle measure. And the input value is going to be the slope. The slope of the terminal ray. So if you're thinking about this though, just like with inverse sine and cosine, if we were simply to take our tangent function, which we can see sort of a mini graph of down below here, notice that if I just, traded my inputs and outputs, I would have multiple angle measures that have the same slope. And we showed that in this earlier problem. We had two angle measures between 0 and 360 that had that same slope of 1.5. So when we end up thinking about the domain and range of our inverse tangent function, we're going to have to restrict it just like we did with sine and cosine. So just a quick reminder, the domain of a tangent function basically exists everywhere except at, the pi over 2, the 3 pi over 2, where we have those vertical tangents. The range is from negative infinity to infinity because our slope can go on forever. So similarly, when we look at our inverse trig, our domain this time is going to be all possible values. It goes from negative infinity to infinity. It's going to be the range where we end up sort of limiting what we're going to look at. And the key here is we're sort of actually only going to focus on this piece of the tangent function graph. And if you notice, that one goes between negative pi over 2 and pi over 2. So if I put inverse tangent into the calculator, those are the only values I could get. And if we think about that on a unit circle, that means we're going to get angle measures within quadrant 1 and angle measures within quadrant 4. But we're then going to need to use symmetry and reference angles to find the remaining angle measures. And this should be something we're somewhat comfortable with now, and we're going to sort of practice doing that in the next few problems. So first off, a little bit of just inverse tangent. So we've talked about it. Let's talk a little bit about notation. So inverse tangent function, we're going to restrict the domain, as we just said, from negative pi over 2 to pi over 2. And this is where we're inputting the slope of the terminal ray and we output the angle measure. And now you'll notice our sort of notation here. So there's sort of two different ways to write inverse tangent. There's arctan, or there's the tangent with the little -1. And if you're using the Desmos graphing calculator, either form is acceptable for entering it. But if you go under the function menu, you'll see this sort of second option. And the same thing on a TI calculator. The second option is going to be the one that shows up. So first, before we dive any deeper, we're just going to make sure we can find this function on our graphing calculator. So we're going to use a graphing calculator to evaluate the inverse tangent of 3.25. So tangent of -1 of 3.25 equals something. And it's not specified angles or degrees. My Desmos calculator defaults in radian mode, so I'm going to use radians here. And so I am doing inverse tangent. Now you can type in the words, or if you go under the function menu, you'll notice that inverse tangent pops right up, and 3.25 was our value. And so we get out 1.272. So let's go back to our 272. And so then let's talk about what our calculator just gave us, because it's important to not only be able to find the function on your calculator, but then understand the numbers that they're giving to us. So if we remember, the key with this is the function inputs the slope of the terminal ray. So when the slope of the terminal ray is 3.25, the angle formed from the 3 o'clock position measures 1.272 radians. Now, keep in mind, this is one possible angle. This is the angle in quadrant 1. And we were simply asked to find the measure in our calculator. If we were asked to get other quadrants, well, we'd have to do a little more work, which is what we're going to see on the next problem. So the next problem, we're actually going to revisit 11. So if we go back, remember 11 was where we estimated our angle measures. Well, Now we know how to use inverse tangent to get the exact angle measure. So we no longer have to estimate. And that's basically what we're being asked to do. So we're going to use our graphing calculator to estimate inverse tangent of 1.5 in our calculator. So if we're going to go over here, now let's change our mode. So remember, we can change our mode by going to that little wrench tool, and I'm going to click on degrees. And I don't want 3.25 this time. I want 1.5. And you'll notice it's about 56.3 degrees. So I was pretty close with my estimate. And this angle would fall in quadrant 1. Just like we estimated. So, you know, pretty good estimate. You know, it's in quadrant 1. And if we think about that second angle, if you remember, you know, we sketched in that first angle into quadrant 1. And if we continued the line through the origin, we had a second angle in quadrant 3. And so if we wanted to estimate the measure, or we want the measure of this angle using symmetry, we have to go to that reference angle. So if this is 56.3 degrees, so is the angle down here. And if you think back, we also know that this whole measure is 180 degrees. So if I take 180 degrees and I add the 56.3 degrees, I'm going to get my angle measure that falls within quadrant 3, and that would be 236.3 degrees.